the square root of -1, it's called an imaginary number because there's no real number that can represent that amount. A positive number, if we square it, is positive, and a negative number, if we square it, it's also positive. So there's no number that I can square to get -1. But we can imagine that there's a number that describes that value, and we call that number I, the imaginary unit. So I squared is the special number that equals -1. And so we can use imaginary numbers. We can use I to describe other sorts of imaginary numbers, like the square root of -9. I can think of this as the square root of -1 times the square root of 9. So I get I times the square root of 9, but that's just 3. So we typically write this as 3 times I. A complex number combines imaginary numbers with real numbers. 15 minus 7i would be an example of a complex number. 15 represents a real part of the number, and 7i minus 7i represents an imaginary part. We can add and subtract complex numbers by combining their real parts and their imaginary parts. 15 minus 7i minus 3 plus 2i is the same as 15 minus 3, combining the imaginary parts, and -7i minus 2i. We have to be sure to distribute the negative sign to both parts of the second number. Just distribute the subtraction to both parts of the second number, so we get 12 minus 9i. Multiplication can be done by foiling or by distributing values, and we'll see that in a moment when we look at this example of division. Division is actually a little bit more complicated. To describe a complex number, I'd like to be able to write it in the form a plus bi. So this is not a very good description of a complex number because I have an I in the denominator, and I just want some real number multiplied by that. So to get I out of the denominator, to complete the division, we can multiply by the conjugate, which takes the same two values, 3 and 5i, but uses the opposite sign. So 3 minus 5i, the conjugate is 3 plus 5i. And so I'm going to multiply the top and the bottom by the conjugate to complete the division by that complex number. So I'll leave the numerator alone for a moment. I get 10i times 3 plus 5i. In the denominator, if I multiply this out, so I'm going to take 3 times 3. We need to FOIL the denominator. 3 times 3. 3 times 5i, positive 5i. Negative 5i times 3. So that becomes like a negative 3 times positive 5i. And negative 5i times positive 5i. So completing the multiplication there, we end up with 9 plus 15i minus 15i and minus 25, 5 times 5i squared, because I need to multiply these two i's together. Up top I can distribute the 10i. I get 30i plus 50, again I squared, 50 times I squared, because I multiply the i's together. But I squared, we saw just a moment ago, I squared is the same as -1, so I can simplify that part. So I get 30i minus 50 divided by, well, here the 15 i's cancel, and that's one of the great things about the conjugate. The mixed terms cancel, so 15i cancels with negative 15i, and 9 combines with the minus 25i squared, but that becomes, this is -1, so this is actually the same as 9 plus 25. And so we end up with 30i minus 50 divided by 34. And we can do just kind of one more thing to make it a little bit simpler. If I want to write it in the form a plus bi, I can write this as negative 50 over 34 plus 25, plus 30 I over 34. And then because all of these numbers are even, I can write it as negative 25 over 17 plus 15 over 17i. So that places it in the form a plus bi and completes the division.